Okay, this is the 3.1 Solving Quadratic Equations Day 2 notes. So the first example says to solve by factoring. So when you're solving by factoring, it needs to equal 0. So if you notice on example 1a, it already equals 0. So then this is where our factoring skills that we've already reviewed come into play. So it's where we multiply to AC, which in this case is 12, and add to B, which in this case is 7. So what multiplies to 12 and adds to 7 is 3 and 4. And because the a value is 1, it's just an x squared, we can write the factors as x plus 3 and x plus 4. And that equals 0. Now to solve, you set each factor equal to 0. So I know you can probably do this in your head, but just to show you what I'm thinking, I set each factor equal to 0 and I solve, so I get negative 3 and negative 4. And those are my two solutions. Now, solutions come from the factors. Another word for solutions are the zeros. The zeros are where the x-intercepts are on the graph. So some very closely related words in this unit is going to be solutions, zeros, x-intercepts. And then technically factors pretty close to that because the factors are what get us the solutions. Okay. So on B, it is not equal to 0, so I'm going to subtract the 10x over to this side so that it is equal to 0. So I've subtracted 10x from both sides. Now I factor. So once again, it's what multiplies to AC and adds to B. So multiplies to 24 adds to negative 10. That's negative 6 and negative 4. So since the x value is, the a value is 1, it's just x squared, I can write x minus 6 times x minus 4. That's the factored form of this equation. So now you would set each factor equal to 0. So when you set x minus 6 equal to 0, you get 6. And x minus 4 equal to 0, you get 4. Okay. And I feel like we practiced that enough. I will put my completed notes out so you'll be able to see any of the examples we skip, but I don't want to waste your time on some of the easier questions. So let's go look at example 2. Oh, I apologize. So example 1D. So find the zeros of the functions. So when they're saying find the zeros, we have this function f of x equals x squared minus 4x minus 21. All right, and so when they want us to find the zeros, that is where y equals 0. What is the solution? So if we set it equal to 0, and we try to solve, then we are going to once again factor. So we're going to say what multiplies to negative 21 and adds to negative 4. All right, that's going to be negative 7 and positive 3. Now if you don't come up with your answers right away, you can always make the list like we talked about in class. Sometimes I don't come up with them on the top of my head. So negative 7 becomes x minus 7, and positive 3 becomes x plus 3. So then you set each factor equal to 0, and so you get x equals 7 and x equals negative 3. So what this tells us is it actually tells us that the graph has two x-intercepts, or two solutions, at 7 and at negative 3. So it's going to cross our x-axis twice. All right. So on this one, I just want to point out E because it says to find the zeros of the function. But if you notice, 2 goes into everything. So I would really recommend factoring out 2 as our GCF and then factoring this trinomial. So it becomes, if what multiplies to 4 and adds to negative 5, that's going to be a negative 4 and a negative 1. So it's x minus 4. Sorry, that's a 4 right there, and x minus 1. So then our zeros, when we set it equal to 0, is x equals 4 and x equals positive 1. So that 2 doesn't affect the zeros, it just changes the steepness and makes it a vertical stretch, so it makes the parabola steeper, but doesn't change the x-intercepts. Okay, I also want to point out f because it was a different case. So if we move everything to one side, I'm going to add the 12x so it moves to the left side and subtract the 48. All right, now everything's on one side and it equals 0. So you need two numbers that multiply to negative 48 and add to 12. And so when I work this out, I cannot find two numbers that accomplish this, and that happens. So when you cannot find the numbers, it does not factor. Now, that does not mean it doesn't have any zeros. It just means that you must find the zeros in another way. So the other options we have if it doesn't factor are by graphing or quadratic formula. So you would have to find the zeros by graphing, like on a graphing calculator, or the quadratic formula, which we will review in another unit to make sure we've got the quadratic formula down. Okay, so example 2, the solve by factoring is a little bit harder just because the a value is not 1. So it's the exact same concept, but the factoring is a little more challenging. So let's do a couple of these. So on a, your AC, what multiplies to AC is 3 times 8 is 24, and what adds to B is 14. So I find out that that is 2 and 12. Multiplies to 24, adds to 14. So then what I'm going to do is I'm going to go ahead and, like I taught you previously, I'm going to use, this is called the area model. So I use 3x squared and the plus 8, and then I use my 2x and my 12x. So now I factor each row and each column. So out of the top row can come an x is the GCF and a plus 4 out of the second row. Out of the first column, a 3x is the GCF and a plus 2. And we're not taking a lot of time on this because remember, this is why we stopped and did some factoring practice previously so that we would kind of already have these skills to factor. So if you set m equal to 0, you'll get negative 2/3 and negative 4. And that would be our two solutions for this quadratic. And if you wanted to check your solutions, you could plug negative 2/3 back in for both x's and type in your calculator, it should equal 0. And then do the same thing with negative 4. Type it in your calculator, and it should equal 0. All right, let's do one more like this, and then we're also going to make sure to visit E because it looks slightly different. So let's go ahead and let's do D. Scroll down here, just because I think D is a little bit harder than the other two. So first thing I'm going to do is I'm going to subtract the 112 so that the equation equals 0. Now I can see that everything is even, so that means there's a GCF of 2. So if I factor out the GCF of 2, I'm left with 3x squared minus 13x minus 56. So when I factor, that 2 will still be just hanging out on the outside as a GCF. So I need to know what multiplies to 3 times negative 56. That's negative 168. And what adds to negative 13. So it took me a little bit of guess and check to find my pair, but I found out that it's negative 21 and 8. So this one's just a little bit more difficult because the numbers are bigger. All right, so I'm going to use the area model to factor. So when I do this, I am just using this trinomial right here. So I have 3x squared and minus 56. And then I use my two numbers I found. So I have negative 21x and positive 8x. So now you're going to factor out your GCFs. So on the top row, 3x is the GCF. And then on the bottom row, a positive 8 can factor out. And so that's 3x plus 8. On the first column, x is the GCF. And on the second column, negative 7 can factor out. So that's x minus 7. So now to solve, you're going to set each factor equal to 0. And you're going to solve. So we'll get negative 8/3. And we'll get positive 7. So it has two x-intercepts or two solutions, and this is where they are at. All right, I wanted to point out E because E is difference of squares. So a quick refresher, difference of squares was if you have two things, it really can be done if they're not perfect squares, but it's nicer if they are. So if you have two perfect squares that are being subtracted, that's difference of squares. And so they can factor by taking the square root of each term and using a plus and a minus. So the square root of x squared is x, and the square root of 4 is 2, and then 1's plus and 1's minus. So that tells you that x equals negative 2 and x equals positive 2. You could also solve this using square roots and get to the same answer. Okay, so let's take a look at what we have left. The monitoring progress is the same. Once again, I'll post my completed solutions so you can take a look at them, but they're the exact same thing we've been doing. So let's take a look at example 3. Okay, on example 3, it says a monthly teen magazine has 48,000 subscribers. Okay, when it charges $20 per annual subscription. So this is very much where this is used in business. So we're going to make a model for each $1 increase in price. So when they add $1 to the price, the magazine loses about 2,000 subscribers. So if they add $2, then it loses about 4,000 subscribers and so on. So we're going to set up a revenue equation. So I'm going to use R of X. R is for revenue, okay? Now, they're starting with 48,000 subscribers, but they lose about 2,000 per every increase. So minus 2,000X. And so X is the number of dollar price increments that they increase. So dollar price increases. So every dollar is a change, and this is what happens. So then the price is $20, but it was increased every 1X, and we don't have to have the X. So every X represents a dollar increase. So this is how the profit changes. So it's a balancing act of figuring out where you can maximize your profit. And so keep in mind, if we're talking about maximizing something, then we're talking about the vertex, okay? So now, to make these a little easier, I'm just going to switch the order here. I'm going to put negative 2,000x plus 48,000. That's the same thing as that first parentheses was. Same with this. I'm going to make it be x plus 20. I just want the x to come first in the parentheses. I think it helps us think about it. So the next thing I'm going to do is I'm going to look and see in this parentheses right here, there's a GCF that can come out. The negative 2,000 can be factored out, and we'll see what's left. So if you need to, I'm going to step out here to show my work. You don't have to, though. So if you were trying to factor out negative 2,000, it's like dividing by negative 2,000. So then you'll see that 48,000 divided by negative 2,000 is going to be negative 24. All right, so this is our revenue function in intercept form. So that means that my intercepts are x equals 24 and x equals negative 20. These are my zeros, also known as my x-intercepts. And so if you remember from chapter 2, how you find the vertex from knowing your x-intercepts is you add them and you divide by 2. And so that's going to get you the x value of the vertex. So 24 plus negative 20 is 4, divided by 2 is 2. So that's the x value of the vertex. And then to find the y value, you're going to plug it back in. So we can either plug it back into where we factored it or to where our original equation is. Either way, if I plug it back in, I get, let's see here, 968,000. All right, so 2 is x. And remember, x was, if you look up here where I define my variable, x was the number of dollar price increases. So if we're doing $2 of increase, then our max profit is that $968,000. So it says, how much should the magazine charge? Well, if they're charging $2 of increase, that means they're charging $22 because you have to add that 2 back onto the original $20. And it will get you a max revenue of $968,000. And so that is their best option, to where essentially the amount of customers they lose due to the price increase is minimal, but their price increase spread out over all their remaining customers pays off, and that gets them the most possible revenue based on their current business model. So really know how to do this equation. You're going to see it again on your homework, and probably on a worksheet review. So this would be very important. Really work through this one and pay attention and read through it a couple times and let me know if you have any questions.